My name is JOSSABELLE. My matrix number is F25A1514 and I'm the leader for Group 8. So now I'm going to present my screen. That is the title of Animal Husbandry Growth Kinetics. So our project focused on analyzing broiler chickens weight grains using derivative in mathematics. In Malaysian poultry system, monitoring chicken growth weight is very important because it helps farmers improve productivity and manage sources efficiency. So the importance for this broiler performance, it helps optimizing harvest timing where farmers can determine the best time to harvest chicken, and it helps health in welfare monitoring by trackers whether the chickens are grow healthily and normally. Then third, it improve feed efficiency analysis, which help us reduce waste and costs. The weight function fx equals to 0.5 x squared plus 10x plus 40, and the growth rate derivative f prime of x equals to x plus 10, where x is h in days, fx weight in grams. So this is the day 0. Calculated weight is 40 gram, and the intentional rate is 10 gram per day. Then layman terms, boarding phase, the phase is low as the chick focus on organ development rather than muscle mass. Then until 13, the phase is also the same, which focus on organ development. Then 15 days, this layman terms, this is focus in period. For feeding conversation, this derivative is increased rapidly until 31, 32, 33. This is also increased. For 34, this layman terms peak growth, the derivative also increased rapidly, but the day 25, 35, the weight is highest and the biological cost to maintain this mass is increased. So harvest usually occurs around this rate. So what is the way that I can increase the farmers, like it can let farmers know the patterns, growth patterns efficiently, and this is and the way that let HTML grow. I think this is we can make an app that farmers can easily just key in this weight function and this growth rate, so the farmer can just like manage and can know these grams and which days they can harvest the.
Good day. My name is MUHAIMIN. My number F25A1894. And today I want to set the present in my interactive biokinesis simulator. This project builds mathematics modeling with real-world livestock management to optimize agriculture efficiently. The core problem focus is beef production efficiently, especially focusing on the indigenous Kedah, Kelantan, KK sector in Malaysia. In animals binary feed translate directly to production cost. Therefore, livestock scientists need to track on an animal accumulator must over time to understand when it is growing efficiently and when its growth begin to plateau. The model this will mod as shape grow function f s square s to track total cumulative weight. By taking the first derivative as f, we can directly calculate and map the growth rate, weekly rate, and given weeks on the animal life. First, Firstly, economic impact, identify the exact time length of maximum growth, help farmers optimize feed formulation, and determine of the cost-effective market processing each. PD and animal park is quick, effectively window, drastically increase production, cost with animal with return. Then I will have impact resources allocation. It allow for data-driven decision in local precision farming, ensuring sustainable management of native Malaysia sucker breeds. Now, let's bring mathematics concept live using interactive calculate point impactor. I want to walk you through how this could hit and analyze the lifestyle the Kedah Kelantan cave by focusing on the indirectly district based on our group class. First, page A, the graph grow spot which the 35 with the 35 with the total mass citing Italy is a kilogram 110 kilogram, which is precisely all our ultimately material weights and growth rate, which 4.4 4.40 kilogram per week. Mathematics, this is a inflection point of our logistic course is the exact moment where the first derivative ratios in the animal mode affecting growth phase. This response, the animal effective growth is the faster the every growth beyond of the specifically which the rate of weight gain will begin declared. Right now, the past suggestions show a diminished alignment, basically height goes when millimeters like 35 weeks. Additive generation point just row number in the graph. To make this HTML application even better, I recommend making the layman biosis insights panel fully dynamics is then just showing static and for 30 bits 30 bits exclude a simple condition JavaScript block to change base where as the click, for example, a click before 35 feet, and clearing grow phase the animal conservation fill the mass fill the mass very efficiently. Thank you for me.
Hello, my name is Muhammad Taufikillah. My metric number is F25B1663. Okay, I want to present about project name Biocalculus Project Kedah Kelantan Cattle Growth Rate. In agriculture bioscience, we all face the challenge of managing living system that don't grow in straight, vertically line. Today, I want to show you how we can bridge the gap between mathematics and biology using calculus speculative to solve a major real-world challenge in Malaysia livestock industry. Let's start with the problem itself. Our project focus on the indigenous Kedah Kelantan or KK cattle, which are incredibly important to Malaysia local beef supply. The biological problem here is to understand how the livestock growth is not linear. It follows what we call sac model or S-shaped curve. When calf is born, its weight gain start off slowly. Then during its young, it enters phase of rapid, accelerated growth. Finally, as it reach maturity, that grows slow and down. Why is study this is important? It's come down to major things: economy and sustainability. First, feed account for the majority of livestock operation costs. By studying this growth curve, we can calculate. We can calculate the average daily gain, ADG. This help farmer practice precision farming, knowing exactly how efficient their animals are any given month. Second, it moves farming away from traditional guesswork and toward data-driven decision by using parameter aligned with research from MADI Research Journal and guideline from the Department of Veterinary Service Malaysia. So let's look at the mathematic modeling. Growth curve function is fs equalized to 2x0 aspect to negative 3.2 step to negative 0.12 x. So we can see the graph here is at the 1 month, the current weight is 16.39 kg. The current is the food that the cattle take is kg per day. So this is after we see this is how the cattle is growing, and this is how the weight. As you click along the graph from left to right, you will notice the growth speed start low, climb higher. It's a peak and start to drop. The peak is most critical point for a farmer. It tells us the exact age where the animal growing is observed fast once the cattle pass this age. Finally, I would like to offer one recommended to make this HTML educational tools even better. Right now, the web page is highly interactive, but if required, to user to manually click around the graph to compare the growth rate. To improve user experience, I recommend adding a dynamic optional analysis summary box directly below the chart. By using JavaScript, the page could automatically calculate the exact coordinate of the inflection point and print the clear summary statement. That's all from me.
Hello, my name is PARTHIBAN MAHEYSAN. My matrix number is FB1697. So today I'm going to show my GitHub, and I want to explain all the criteria I want to speak about. So first, my title is MD2 Pineapple Maturation Kinetics Interactive Directive FX Simulation.
0.1.
My GitHub focus is harvest, logistics, and bioscience processing sustainability. As you can see here, my main page is structured as a repository to be fully open source, disposable, and documented so that anyone in the bioscience community can clone it and build up upon our work. Let's dive into trying to solve. So, what is the core bioscience problem we are tackling? Our project focuses on protein misfolding disorder, specifically looking at amyloid beta aggregation in Alzheimer's disease. In healthy brain, protein falls into precise three-dimensional shape to do their job, but in Alzheimer's, these proteins misfold, turning into sticky plaques that disrupt cell communication and lead to the widespread neurodegeneration. Our repository contains a machine learning pipeline designed to analyze genomic and structural data to predict which specific protein mutations are most susceptible to this dangerous misfolding behavior. Now, we move to the importance of studying this problem. First, neurodegenerative disease currently affect millions of families worldwide, and the economic and emotional toll is staggering. Traditionally, laboratory methods to make protein folding like X-ray, crystallography, and months or even years painstaking trial error. Okay, now look at this repository correlative function. This growth function is fxl1 plus e minus k, and first derivative growth rate fxltek minus 1 plus e. Right, so this is our total fruit from week 0 to week 24. As you can see here, by total weight fruit is going up to week 16 and go down until to week 24. Right. What is the folder does take a raw message genomic sequence from public database and filter out low difference rates. It standardizes the data so our models don't encounter formatting error and later on. Point 2. Feature extraction and training. Inside the script, we praise the physical totality amino acids like hydrophobic and charge. This meaning behind this point is to teach our program how to physical chemistry of a protein influences its final shape. This is where the actual problem happens. Point 3. So this point crucial because it holds our confusion matrices and ROC curve. In bioscience, a false positive could mean wasting millions of dollars on a bad drug candidate. This section proves our model separate at a 92 accuracy rate, giving researcher confidence in data. So, section 4. How recommendation for better HTML. Now, if you look at our project front-facing HTML project page or GitHub page layout, it does the great job of displaying the raw. However, there is always a room for improvement. Right now, my HTML page only displays two static images of our protein prediction. By embedding an interactive 3D viewer directly into HTML Canva, user could click, drag, root, and zoom in the prediction mix folder protein right from their website. This transforms the pages from a passive reading document into an active immersive scientific tool. If you want to test the model yourself, feel free to follow this repository and check out the installation guide in the README and start running your own sequence. All right. Thank you so much for your time and keep pushing the boundaries and computer biology. All right. That's all for me.
เธออย่าเพิ่งท้อนะเธอไม่ต้องไปกลัวนะโชคชะตาสักวันมันคงเข้าข้าง